Good morning, good afternoon, and good evening. My name is David Meltzer. I'm the Secretary General of GVF. As many of you know, GVF is the global trade association representing the entire satellite ecosystem. And hopefully you're aware, but if not, I'm pleased to inform you that GVF and our board have decided with the board of GSOA to combine the two global trade associations in order to give the industry both broader and deeper representation and increased impact on behalf of all of the members, which are now totaling 70 different companies. So it's my pleasure to welcome you to this webinar as part of our ongoing webinar series in association with Connectivity Business News. And I very much want to thank today's sponsors of the webinars, which are the creators of the new online training material for those in the space and satellite industry. It's called Space Business Qualified. These online courses really are a great way to train or onboard new staff, broaden the knowledge of existing staff who are looking to perhaps, in addition to broaden their knowledge, grow their effectiveness, increase their potential for promotion, and also the new courses are a great way to entice or recruit new staff. Additional information on Space Business Qualified, it's available at spacebq.org. Let me now introduce our excellent group of panelists. The first person, as you see, Albert Ifra. Albert is the satellite connectivity business development person for Orange Business. Jack Buchler, who is the vice president of business development for Italia. Next, we have Nimrod Capone. He's the founder and CEO of Oasis Networks. And finally, we have Amir Kashani. He's the director of system engineering at Spacebridge. So, gentlemen, welcome and thanks for participating in this webinar. I'd like to begin just to make sure everyone in the audience has a common understanding of when we talk about connecting antennas and satellites, what do we mean? And just briefly, I think the audience is probably very knowledgeable, particularly about the satellites and the ground segment, but obviously a lot goes into creating a communications link. And your companies, network solution companies, they all provide products and services which really ensure that satellite communications are efficient, secure, reliable, and optimized for their intended purposes. And this webinar will really explore what goes into providing these critical links. And Nimrod, if you wouldn't mind, just take a minute to make sure the audience has a common understanding. When we talk about the links that provide communications, satellite communications, what are we talking about? What are the basic links? Nimrod?
Thank you, David. Well, satellite, of course, is about connectivity. So basically, we are looking on, we have the satellite, which we can consider it like a mirror in the sky. This is the way I like to describe it. And then we have the teleport, which is usually a big facility connected to the international fiber backbone, and with all the facilities and redundant electricity and redundant connectivity and so on. And this satellite and the teleport are there to provide the service, the connectivity to remote sites. So basically we have, of course, we have antennas at the teleport with the amplifiers, with the receivers, with the modems and so on. We're not going, we can drill down to and talk about it hours. And this big facility basically is there to provide the service to the remote sites, which are much more simpler. Usually they consist of smaller antennas, simpler BUCs, LNBs, simple modems, and so on. So the remote users will be able to have affordable solution, easy to install and maintain, and provide end-to-end connectivity from wherever the site is, over the satellite to the teleport and to the international fiber international network. So this is really in a nutshell.
Okay, well, thank you, Nimrod. I appreciate the overview. So let me go to my first question, and I'll stay with Nimrod, but obviously would welcome the thoughts from the other panelists. And so, Nimrod, the first question, as you walk through the chain, and I love the analogy of the satellite being a mirror. What, from your perspective, is the biggest network challenge or complexity faced by you and your company, which sits between the antenna and the satellite?
Yeah, okay, thank you for the question. My perspective is more coming from the field, from the remote sites. So there are many challenges also at the teleport, at the satellite itself, and so on. So from my point of view, I'm going to mention only what I face on the field, what we face. Of course, the situation on the ground, I think satellite is a very curious sector in the global telecom communication, because when we think about the telecom world, so usually there are standards and there are very well-established procedures, and we're talking about telecom companies which share the same, I would say, standards and point of views and so on. But when we are talking about satellite, we are reaching out to remote customers when in different countries, and our end customers usually, most of them, they're not telecom companies, and they don't share the same perspectives, and they don't take for granted what we take for granted. So in my point of view, what we see on the field is that there are many, there is a very big gap between, I would say, the big established organized telecom companies, the teleports, the service providers, satellite operators, and what is actually happens on the ground. So I think that this gap, the overlooked issues, all the small and big points, God is in the small details and the devil as well. And I've seen so many projects which are being delayed and redelayed, and you look on after the law, and again, the project delays even more and more and more because of local regulation that was not considered, or just how to release the equipment from the customs, or the weather conditions. When you're looking on a server room, it doesn't really matter how's the weather outside, but when you need to install a VSAT, so you need to consider the weather, the access to the site. Sometimes some sites are not reachable during certain months, and then you just have to wait. So there are many things along the way on the field, which maybe telecom companies or project managers that they sit in the air-conditioned room, sometimes they just, it's very difficult for them to be aware of. So from my point of view, this is the main challenge, establishing the link and maintain it in a good way.
Thank you, Nimrod. So it sounds like, particularly for smaller companies, a lack of awareness of, some basics that I think larger companies perhaps have the resources, are able to predict at least. Albert, let me turn to you. I mean, Orange Business, obviously a very large company. I think a lot of your customers are similarly, very large. What's your impression of what is the single biggest problem or greatest complexity that you and your customers have to deal with in the world of satellite communications?
Yes, it's true that Orange Business, typical customer or big corporations that have, I would say, they require some kind of standardization in the way we are implementing the thing, and an industrialization of our rollout process, but it's true, I agree with Nimrod on the fact that we are facing with the satellite connectivity some complexity that, from our perspective, are more related to the specificity of the countries where we implement satellite connectivity, and we can face some custom issues. We can face some compliance related issues in the kind of countries where our customer have presence. And well, this is from our perspective in Orange Business, the main concerns that we have, because we are, we guarantee to our customers that our process, our compliance with the law, that we are not exposing them to any penalties or any issues. Whatever, or any risk related to even tax, tax, export tax, and etc. So our value is to bring some homogeneous process across, then to absorb all those specificities in the countries, specific constraints that we have in the countries.
Great.
That's most of it. Yeah.
Thank you, Albert. So government requirements and compliance obviously is top of mind for you and your customers, and looking to Orange Business to help solve those government requirements. Jack, Amir, what do you see as particularly the most significant network challenge?
Besides Nimrod and Albert's comments, which I totally agree with, being more specific now, when a customer, as already been mentioned by Nimrod, people organizing terrestrial circuits are used to getting a quote, payment, sometimes in the particular countries. In fact, I'm in central London, and it took 6 months to get a circuit connected here by BT. So, but in the end, it was connected, and it's worked ever since. When you go to some other places, they expect the same thing from a terrestrial circuit. Now, when we switch to a satellite circuit, after all of the mentions that Nimrod and Albert have said, which I completely agree with, and we have those battles all the time, we then find the C-band may or may not work. And that is a major problem, particularly in Africa, where there's in some places very heavy rain. You'd expect the C-band to be protected. In some countries, it's not protected. And in some cases, nobody knows the answer anyway. So you have to go and try it, then to find out that actually it doesn't work. So let's switch to KU band, a different frequency band, and all the equipment needs to be changed. And end users, they don't understand that. Because when they order a terrestrial circuit, yeah, it takes time to dig the road up, or however long it might take for whatever reason. But in the end, it's delivered, and that's it. They don't have to consider the considerations. Again, Nimrod and Albert already mentioned most of them. And there are additional problems with satellite. The good news is, unlike fiber, the services end-to-end are calculated mathematically and can be delivered to that mathematical standard. Fiber circuits cannot. They're randomly disconnected for whatever reason. And if you've got a long circuit, it may even be 2 or 3 providers providing those services, and the chain is broken somewhere, even on a redundant service. You don't know where it's broken or why it's broken, how the availability is connected. So I think satellites sometimes can provide the better solution. That's not exactly what you asked, but certainly we're finding now C-band is, by regulators, may be permitted, and we had an answer recently of you can use it, but 5G services may use it in the near future, and therefore we cannot guarantee it will work in the future, and we're not protecting you either. And that's in a European country, by the way, not an African one. So you therefore don't use part of the C-band right away, and that has its issues as well, because then you have to find a satellite with the right connectivity on it to give you that. And recently we had one to go from our new teleport in Germany, from Germany to Beijing, which would be using an old-fashioned C-band global beam. Low power, yes, but it reaches. There was fiber there. In fact, there were 2 fiber circuits at that location already, but just in case, they, and this was for a European embassy, and they, on one satellite, couldn't do it because it was on extended C-band, and extended C-band these days is not protected. So find another satellite, and there aren't that many satellites that can do global C-band at low power anymore. Nobody wants it. So we wanted the reach. So that's one example, real example.
Thank you, Jack. Can you hear me? I think I might be having some issues with Zoom on my end.
We can hear you.
You can, okay. And apologies to you and the audience if there are issues. Amir, what's your perspective? I mean, Jack has just talked about an important issue having to do with regulation of spectrum and the fact that in many countries, when we're talking about C-band, it is being reallocated in some portions of that frequency band from satellites to 5G services. So making sure that your customer, the equipment, is all up to date in terms of what the then current regulations are is critical. But Amir, what's your perspective in SpaceBridge, and how does SpaceBridge overcome these big challenges?
Let me take the question to another aspect, which is the technological challenges. So Jack, Martin, and Nimrod talked about regulations, about operation and challenges, which is great. But since I'm from the ground segment is whatever is on the ground. It's hub, terminal, or gateway, what we call. We are linking the terrestrial network or customer traffic to the satellites. So I want to talk about a little bit about the technological challenges here. Since the terrestrial network and the satellite, they don't understand each other. We are the translator here. We are the middleman here. We don't get involved in operation too much, but there is a big challenge right now in the market. There are new satellites there. There are software-defined satellite networks, mostly in GEO. And there are new LEO constellations, OBP, with hundreds or thousands of satellites there. On the other side, this is our right hand. On our left hand, there's a terrestrial network. There's new 5G, MEF, all the software-defined network. So technology is evolving. And these two guys, the right-hand guy and left-hand guy, they don't talk to each other. So the satellite guys don't really follow what is on the terrestrial or vice versa. The biggest challenge for us as a ground segment vendor is how to comply with the new satellite technologies like software-defined satellite networks that we have to have a huge orchestration, the new capacity requirement in the markets. Previously, it was 36, 72 megahertz beams. Right now, one satellite system is going to provide hundreds of gigabit per second or terabit per second. And the demand from the ground segment, which is 5G, MEF, and software-defined network, and mostly virtualization. So the operation is always a challenge, but the satellite system has to catch up with the new development. Otherwise, this operation of the traditional system will eventually die in a couple of years. So the biggest challenge from our side is how to be able to translate and how to be able to facilitate this link between the terrestrial network and the new satellite constellations.
Thank you, Amir. And I'm going to stay with you for a related question, but yeah.
Maybe I would like to add something on what Jack said.
Please.
Yeah, which is a very valid point, because we have been talking about the remote location where we face all the mostly regulation problems and administrative issues, whereas in Europe, Orange Business have simply stopped using C-band, and we are exclusively providing KU band to provide connectivity in Europe for this particular reason of the possible interference with the 5G. And I would like to add one thing is, in particular in Europe, we have emerging requirements, new requirements that comes from the end of the copper. When customer used to have an ISDN connection, which cost which is very low cost, and there is the end of the copper access, like in France we do. We are ending that. Some location will not be reachable with the fiber. They will not be eligible to fiber. They will not be eligible to 5G neither. And the only remaining solution is satellite connectivity. Okay, and I mean, to comply with the level of cost that we have on ISDN, typically it's quite a big challenge for satellite, mainly because of the capex, mainly the cost of the antenna, and to make it simple. And we see some emerging new technologies for very small antennas. I'm thinking in particular for sites where there is no people, where it's mainly IoT that would require a low bandwidth connectivity, but the challenge is to provide a connectivity at a level of price and without a big capex to put it in place. And then with the traditional satellites, we see that this kind of new antennas are not always working because of the power of the signal, and this is going to be resolved by high throughput satellite, which provides a more powerful signal, and therefore allowing smaller terminal and cost-effective terminals. So in Europe, I would say there is some new requirements that are appearing due to the end of the copper, and also that is not only what we think about when we speak about all the high throughput connectivity, the low Earth, the satellite, etc. That doesn't necessarily respond to this kind of requirements.
Thank you, Albert. So very much building on what Amir said, the innovations that we're seeing, whether they be regulatory innovations or technological innovations, are creating the challenges. Nimrod, you wanted to talk about this point? And let me just a sec, Nimrod. Just remind the audience, we're starting to get some questions through the Q&A button. I will be taking questions from the audience shortly, so please feel free to put your questions in through the Q&A button on the bottom of your screen. Nimrod, please go ahead.
Yeah, I just wanted to add something small. I think what Amir highlighted is very, very important, because I would like to zoom out a bit. Let's look on the market, let's say 20 years ago, before fibers, before 5G or even 3G. And well, especially in Africa, we could see so many VSAT links for cyber cafes, for small offices, and so on. It was the only mean of communication. Today, the customers who are using VSATs, there are more and more, I would say, high-profile customers. And it's not a cyber cafe that you can allow yourself to provide them bad service, because they just, I don't know, they will never pay, and they're small, and they don't need a lot of whatever, they cannot pay much, and so on. And this, I think also that the satellite industry became more mature from my humble point of view. I think before the market was more like a Wild West, and on the field, uncertified, unqualified installers, everyone tried to do whatever they can, and there weren't so much resources, and everyone just did what they could, the best they could. But today, I think when we look on the future, we're looking on merge of networks, that the satellite will be part of a global network, global customers that have maybe different connectivities in different countries, and satellite will be one piece of the network. And the challenge is of course also a technological one, how we can provide a good service, a good connectivity, good different types of applications as well, and so on, and to do it over satellite in remote areas, and again, where the situation on the ground sometimes is not so simple. And so we have like some kind of, it could be a good solution, it can be also a big gap, because the demands are getting higher and higher, but if the performance on the field just unable to provide the good service, so it will not work. So I think that the direction really, I think we need to look on the weakest link in this chain. I think that the weakest link now still is the operation on the field. And I hope that we are improving this aspect and to allow a better connectivity to the end customers eventually.
Thank you, Nimrod.
Yeah.
So
I think,
go ahead.
yeah, I think we are moving to the ground segment and all the problematic that is around that is behind the satellite connectivity itself. And here I have to say that you need Orange Business because obviously we have assets all around the world. We have, I mean, our core business is to provide global network connectivity, and we are putting a lot of intelligence in our network moving forward, and that's our, I would say, our key differentiator. We are talking about telco cloud platform that provides global reach, global connectivity, and that behaves like the cloud. And obviously, what we do in Orange is to interconnect everywhere with all the cloud service providers. Okay, and it gives us an ability to provide private cloud connectivity even to public cloud providers. And when we know that corporate companies have massively moved and are still massively moving to the cloud, it gives us the possibility, gives us the ability to provide to our customers to connect everything, everywhere, to access application wherever they are located, and to bring a secured orchestration of all that, which is something that requires an infrastructure. And well, that's not the business of a satellite, a typical satellite provider. It's the business of a telco, and yeah, that's, I think that's what we believe is our value proposition, is to be able to provide a combined expertise on security, on connectivity, on cloud, and proper orchestration. Having said that, the satellite is a particular case of connectivity. That's and completely integrated into this network offering. That's basically the positioning, and that's why we keep doing satellite. That's why I mean, it's not our core business. Satellite is not our core business, but that's the reason why we keep going. We keep satellite in our portfolio, and we maintain and we keep our portfolio updated with the new offers and the new partnership with the new. I will not give all the names, but with the emerging provider in the satellite field, because it complements our portfolio of connectivity.
Understood. And I think, Albert, you've talked about the value proposition for Orange Business, but I think all of our companies represented on this webinar help provide solutions to people and companies who are challenged by, among other things, and it's been touched upon, some of the innovations that we're seeing both in space and on the ground. And there are two innovations that have been touched upon, and I'd like to focus a little more before turning to the questions which are now coming in from the audience. We've touched upon the fact that now we're seeing high throughput satellites and very high throughput satellites are being launched now. So greater throughput, greater bandwidth, greater connectivity, and also the emergence of satellites in low Earth orbit. And I'd welcome the panelists' perspectives on how are these high throughput satellites, these low Earth orbit or LEO satellites, what does this mean for you and your company in providing solutions to your customers? And let me start with Jack and Amir and get your perspectives as well as the other two panelists, and then I'll turn to the questions which are now coming in from the audience. So Jack, LEOs and high throughput, very high throughput, what's your perspective?
I'm going to divide my answer into two halves. First of all, for the end user, what does it do? How does it help? We already operate a significant amount of capacity in Ka band on high throughput satellites. What that's done is allowed customers to go to much higher bandwidths than they could go before. But of course, notwithstanding the fact that LEO, and we already see Starlink in action, how that affects the end user. And we see some, I know one of my customers, they were quite happy to have 4 Starlink terminals on their roof and use that as their backup. So they had over 400 users on those 4 terminals, by the way. So how does that fit in, as in your question? So the answer is, I think that the geo operators will have to drop their prices or somehow give greater throughput or a mix of both, because the market's very mature. So the equipment to actually access large bandwidths on geo is there on a dedicated basis. And I think Nimrod or Albert both would probably agree with me that the customers want not only ever increasing bandwidths, but ever increasing reliable bandwidths. Quite often these are used as backup to the fiber, and it has to be there when they need it. So that mature technology plus the dedicated bandwidth, and not all of the operators offer at the moment dedicated bandwidth, they all will in the end. That's really the key. So that's one side of the problem. The other side is the actual LEO operators themselves. How do we as a service provider help them? And the answer is we have something called a LEO park. And a LEO park, probably not heard that name we use internally, is to have a location. Our teleport is one of them. We have multiple teleports where they have their gateways, and gateways can share commonality of data connected through our data center. So now you can have one user on one network and another on another, and it's only going through the gateway, so located in our LEO park. So we're already making strides, and we have a number of, you can probably find out where some of these people are by looking it up. Some of it's public, some of it's not so public, but so we're not saying don't use it, but what we are saying, the actual key message here is users want end-to-end quality connectivity, LEO, GEO, MEO, and we're operating in all of those markets. It doesn't matter. They have to have quality service at both ends. I hope you'll ask later how we're pushing ahead in that area, but I won't answer that now. But end-to-end quality service, that's the key here.
Thanks, Jack. So just to echo, customers tend to care not what orbit, they care about quality, end-to-end, reliable, secure service. Here,
sorry, I wanted to also add that make it simple. And we already saw Starlink making it very simple. One of the things we've done 2 areas. One is the idea of portals. Again, what I'm saying is not that uncommon. I'm sure most operators doing this now, but we have portals for payment. So users can top up their service. This was an issue once upon a time. I think Nimrod mentioned that. And we had many of those cyber cafes and they didn't pay. And how are you going to go to country X and get the money? You can't even get a visa to go there. It takes 2 months just to get the visa. So that was an impossibility. Now, just like your mobile phone, you do mobile phone top-ups, you can do that on satellite services. So that's an important one. And the other one is management. How, we promise to give you a dedicated service. We'll prove it. And one way we're proving it is through the web. So you can go on, and everyone's doing that. But those are the things that make the difference. If you're not, once upon a time, we did not offer that. This is how the market's matured as a standard. You have to offer those things. Good.
Amir, your perspective, LEO's high throughput, other technological innovations. How is this changing the industry, and what are the challenges that come with it for SpaceBridge?
Let me again look back to the technological parts. I start from LEO, I'll go to the VHTS. The LEO, new LEO constellation, especially with OBP onboard processing, opens up both of these networks. They open up new markets. And this is very important. Of course, the traditional market is a revenue generating market, but we also have to have an open eye to the new markets. So LEO onboard processing is like that the actually modulated traffic goes to the satellite. It's opened up to the Ethernet frame and it's re-switched or repacked or rerouted in the satellite. So the satellite acts as a terrestrial switch or router. What's the market it opens? Of course, it's a very high-end market. Imagine the banking system, the really real-time applications that the seconds are important, trading applications. These things are for that market. Just give you a simple example. If someone from US wants to trade in Japan market over this OBP LEO because of the propagation delay, can have double the speed of the fiber, which means millions of dollars in trading. So these are new markets. Industrial IoT is another application for LEO that some companies have started working on that. But on VHTS, I would step one step ahead of the traditional VHTS. I'll go to software-defined VHTS. Software-defined VHTS, again, what markets are open? For example, in-flight entertainment. For example, some of the companies, they have follow me beam. A beam can follow the airplane. Imagine the real in-flight entertainment. If it is really accessible for everyone and everyone wants to use that, it means hundreds of megabit per second or even gigabit per second per plane, per airplane. So it means that the traffic capacity, the QoS to that airplane is very important. The congestion, the quality of service of the targeted beam is very important. So these are opening up new markets. But one of the markets that no one has looked at that for now is cloud backhaul. Do you know how much is the cloud traffic, the projection by NSR by 2029? Is 52 exabytes. It means 52 billion gigabytes. What's the revenue projected for the satellite is $16 billion. So this market is a new market. That's the cloud, everything is moving over cloud. And the cloud needs the backhaul, needs the traffic to pass anyway. And this cloud traffic is huge. So the new VHTS software-defined satellite networks is a good target for that. But what is into that? The most important thing into that is using AI and machine learning for orchestrating the for dynamic resource management. We always compete on waveform efficiency. My waveform is a little bit more efficient than your waveform and this and that. But dynamic resource management, what it gives us is close to 100% usage of the network, which is very important. I think there are new markets opening up by these two generations of the new satellite. and most importantly, to be, I would say, competitive on that market with terrestrial network, we have no choice but going to virtualization and using machine learning and using some intelligence from the machine.
Thank you, Amir. And you've touched upon, and I'm going to go to questions we're getting from the audience. The first question is, what is the position of satellite connectivity industry in providing cloud computing services? And Amir just talked about cloud computing and the potential for it. And certainly satellite today is very much part of the cloud network. But want to open it up to the other panelists and your perspectives on cloud and satellite. Who wants to address that topic? Okay, Jack?
I was going to say, of course, these questions are coming out at random. There was a satellite, which I can't remember what the name of it was, that was launched with a Cisco router on board. And the idea was, as Amir said, to pre-process and reprocess packets. And it was a bit of a failure. Well, I'd say it's a bit of a failure because it was never repeated until very recently. Why was that? And that was because once you send the hardware up into space, you're stuck with that hardware. So as we know, hardware has to be tested and for space applications in particular and verified. So they're always a couple of generations behind because of the time it takes. So actually, you're landing up with an OBP that isn't absolutely the latest and greatest. It is not like taking your, I don't know, Apple processor, you know, the latest generation that they have, and loading it on the satellite and off you go. So the idea was not a great success. In principle it was, but once they had bugs and hardware issues, they couldn't always sort them out, and you could hardly pull it back. So I'm of the opinion that the satellites should be left as is, and the ground segment is the bit where you can go and change a router for the latest one or whatever you want to do, and leave the satellite alone.
But does the software-defined satellites, does it address the lack of flexibility when you put hardware up in space?
Satellite, if someone remembers the name or can type it or tell somebody, then that's fine. It was going back a little bit. Were software-defined? That's my whole point. Yes, they were software-defined, but you can only change so much in software definition. You can't change the CPU or the memory. Oh, we need more memory. David, would you like to be the person to go off and change it? Of course not. So that's what I'm saying. It's better if it's on the ground because you can physically go and touch it as opposed to.
Let me disagree a little bit with Jack, with all due respect, Jack.
Okay.
Please.
First OBP was commercially a failure. I agree. And the problem is putting the hardware there. That's exactly the key. That's exactly the evolution that we have to see right now. So we are always behind the terrestrial network, unfortunately. It has always been on the satellites. What is a cloud and what is a virtualization for? The cloud and virtualization looks like is for just lowering down the capex. What's much more than that? So if we have software-defined networking, we only need a generic hardware on every satellite, and there's no update because it's always software-defined, it's always virtualization. This virtualization is the key. If we have virtualized cores on the ground segment and on the satellite, it can expand drastically. Just give you an example. Right now, how these clouds work, even the security concept, even the reliability concept, there is an application. There are tens of virtual machines supporting this application in the background, and these virtual machines are supported by some hardware all around the world. If one, let's say, data center is completely down, the other data center take over. So I think it's a key. The OBP so far was not successful, but if we can combine the OBP concept with virtualization of the software-defined network on the satellite, I know there's a limitation of the resource management. I know there's a limitation of space, power, and all these things. But hopefully, we are talking about 2029. We are talking about years from now. hopefully the OBP on the satellites, I would say it will be achievable.
Actually, you and I were both working on a special project where it was mission specific, and where it's mission specific, then it is the OBP, don't get me wrong, is a good idea. And that was on Hispasat-1. And Hispasat-1 had an OBP which was very successful because the VSAT hub was on the satellite itself. So you could send a signal up to the satellite down to a remote, or remotes could talk to each other without having a mesh type network. So that process was very successful indeed, because they were using standard terminals instead of mesh terminals, which are always very expensive and very complex, and also have all sorts of issues with carriers and size and lots of other issues. So that actually, the principle of it would be to almost do away with the teleport, except for telemetry and control. So don't get me completely wrong. I can see where we're going, but the experience wasn't what it needed to be, because again, the end user expectation couldn't be met because of the space requirement of thorough testing and verification, and not being able to use the latest processors. I think if you look at the shuttle, it went up with a 386 processor in it when we were far advanced on the ground, because that was all that was allowed at that time, that was actually verified. That's just my example. So don't get me completely wrong. The idea in principle is good.
Okay, well, thank you. We received a few questions that I think the panelists have addressed on LEOs and their impact, but there is one question that I think has a degree of specificity. I'd like to get the opinions from the panelists, and essentially it's talking about, you know, the challenges for MEO and GEO that LEO systems are posing, and the question is, are LEO systems expected to satisfy the demand for high capacity specific to maritime? So if anyone on the panel wants to speak to the potential for LEO and how it will compete for maritime business with GEO and MEO.
Well, I can take this one.
Please.
Yeah, obviously, the challenge on maritime is, I would say, significantly the same as with terrestrial, and obviously the LEO is expected to phagocytate, to take the market share that today we have with GEO. That's mainly because of the cost of the terminal and the flexibility, the bandwidth that it provides. The requirements on maritime for high bandwidth is increasing as the regulation impose the ship owners to provide crew welfare applications, to do IoT, to do reporting on the fuel consumptions, and a lot of applications like that requires bandwidth at sea. Obviously, the LEO is expected to make a difference on that, because today the capacity is expensive. The KU band that we bring geostationary is expensive, and LEO is expected to change bring a significant change. But getting back to the LEO versus GEO and how we are taking this change. I mean, as far as Orange Business is concerned, for us is a no-brainer. We are integrating the LEO offers in our catalog. We have a contract with OneWeb, and we are under finalization with Starlink. And I mean, we are obliged, because our customers are asking that to us. But this is bringing some change in our business model, because obviously with those kind of offers, we are not using our teleport, and our infrastructure is becoming more and more unused. I mean, our cost, we were unable to leverage those costs with those services, and it is becoming the global economics is becoming problematic because of that. Because at the end of the day, the remaining services that are using our teleport, and I'm not saying that we are not foreseeing any use in the future for geo, we do, and so we need geo. We will still need geo for many applications and for many usage. I'm thinking about all the governmental requirements and all sovereign requirements and these kind of things. We will still need geo and so on. And our teleport infrastructure is going to become more and more expensive, and it's going to bring additional charges on the cost of the geo solution. And this is the main issue that we're facing, because we cannot incorporate the cost of our infrastructure into a very competitive offering, because I mean, the Starlinks and the OneWeb of this world, they are giving to every reseller the same similar conditions, I would say. So we cannot incorporate the cost that we have of our teleport, of our infrastructure into our price for Starlink service and OneWeb service. So it makes us be having some competitiveness issue, and maybe at one point in time we will have a choice to make. That's the change of the paradigm is maybe imposing at one point in time that we may have a choice to do.
Thank you, Albert. And so you've highlighted a factor of LEOs that I hadn't thought about, which is you know the LEOs are bringing the teleport to the consumer or to the end customer, if you will, and that provides opportunities as well as challenges for teleports. What is their role? There is certainly a continuing role with respect to geos, but as you highlight, that provides challenges. Nimrod, you were looking for the so let me go to Nimrod, and then as we're approaching the top of the hour, ask a final question. But go ahead, Nimrod.
Yeah, just a couple of quick things. First of all, LEO is a fact, I think, and but I think that geo is here to stay. We have the CIR. We have again the level of service that we can provide in the geo platform. In terms of CIR is much better than the LEO. Second, we see the high performance and the low price of the LEO now, but we don't know what will be the price in the future and what bandwidth they will be able to provide. Plus, I think that the requirement will increase, the demand will increase more and more. So I think there is enough space also for LEO, also for GEO. This is my personal opinion. Second thing, which I think
only about, sorry to interrupt you, but don't think only about Starlink. OneWeb is providing CIR.
Yeah. Okay. Yeah. But still, again, I don't want to get into LEO too much. You know, there are also some other limitations. How many satellites you can put in orbits, and the debris and the regulation about it. So there are other problems. But I would like to highlight another thing is that that maybe is overlooked. When a field engineer arrives to the site, he also acts as not only a remote hands, also a remote eyes, and is also represent the service provider. With LEO, there is some kind of risk that terminals that being installed by the end customers themselves. There is also kind of risk, the way I see it, that the personal connection between the provider and the customer is somehow affected. When you are a telco, when you provide a service in your own country, so the things are different. But when you provide a service overseas, And when your customer is, again, we're looking on high profile customers that you need to give them a good service. I don't think that it will be a good option to just to send them a kit of do it yourself and install a flat panel on the rooftop and that's it. So this is another point which I think that could be considered.
Thank you. Amir, were you asking for the floor?
I just want to add one thing. Again, another forward-looking idea for any kind of maritime SATCOM on the move mobility. I think the future idea is thinking about multi-orbits, not only what about the LEO or what about GEO. I would say the multi-orbits probably is going to resolve the coverage issue, resolve the type of application issue, and resolve the cost issue, because at the point for a specific application, LEO might be more cost effective than GEO or vice versa, or better quality. And all these things can also merge with 5G. So if we have a link that, if we have all the means to pass traffic over 5G, cellular 5G, I mean cellular 5G or LEO or GEO, and according to the specification of the traffic, cost, delay requirements, real-time applications, we choose dynamically what link to choose. And one more thing in future that I would say I would like to see that it happens in next 5 years is interoperability, and is actually handover of the users between satellite service providers, like exactly what happens in cellular service providers. So you go with your cell phone everywhere, you go to, from Telos, you go to Rogers, you go to everywhere, and it's working. And I really hope someday it happens also in the satellite environment.
Thank you, Amir. Jack, I wasn't sure, were you asking for the floor?
I just wanted to, yeah, please. I'm going to just say two things as quickly as I can. One is we operate and have operated hubs for 25 years. We have a number of different hubs from a number of different vendors. And the reason we operate them in the way we operate them is that they can do broadband and they can do dedicated services for high-end enterprise customers and very high throughputs for some really high-end customers. So what we learned was from that is that the LEO operators can also do the same thing. Whilst some of them may today say there's no CIR, in fact, for management purposes, they have just put 0 in the CIR box. But it would take them no time at all not to change that to some other number, and therefore could offer it just a switch, just literally just like that. And the industry, the GVF and all its members should be clear, and to the people listening, that that could be the case tomorrow. So in order to do that, we should all be wary of that and take that into account in our day-to-day businesses. Now, one of the things I'm going to say is a bit controversial, and I've said it about 2 years ago, and that is the idea of reverse payment. There might be a situation where a business model pays users to be connected, and you'll say, well, pardon? Aren't we talking about a business model where the end user pays? And the answer is not necessarily. There are lots of websites you can go to. If you buy something through their website, there's some sort of payment back which they get from their vendor, and they pass some part of that on to you. Quidco in the UK is one of them, but there's hundreds of them. So why is that not applicable on the satellite, particularly the satellite broadband market? So I think that could be something coming up in the future, where the other thing is difficult sites, where Nimrod was talking about. We have some sites which are only accessible by helicopter. The helicopter only goes there 2 or 3 times a week. What happens if there's a fault? Well, we're starting to use these goggle type things where we can see, we give it to the customer and the customer can see what's going on. We can see what the customer's doing rather, and see where their problem is before we get onto the helicopter and bring the parts. So we're actually seeing, we're advising, literally seeing, as you see me right now, telling them, yes, that red light shouldn't be on there. You can do it with a phone, but it's not the same. Now we're doing that. We're doing scripts. We're starting to write scripts for maintenance and for checking and things like that. So it will step through. Those things make the difference. Leo, Geo, Mio, I don't care. Difficult to get to sites. The IT guy can now be a satellite engineer and help us at least on the first level to do that. And we think that's a great help in the service area.
Thanks, Jack. And all the panelists have touched upon innovation in the future, and I'd ask them a final question. And for those of you who have asked questions through the Q&A button, we're going to run out of time and not able to answer all of them, but please go to gvf.org probably tomorrow to see at least we're hoping to have written responses from panelists to the questions that came from the audience that there wasn't yet opportunity to ask live. My final question, and at various times in the last hour, we've heard a lot about LEOs, artificial intelligence, machine learning, software defined, very high throughput satellites, and interoperability was recently raised, which is one of my favorite topics. Gentlemen, if you had to peer through a very murky crystal ball, what would you see in the next 5 years as any one of those innovations, or something we haven't talked about, as mostly or most greatly impacting the satellite industry and your company's business? What innovation, whether it's LEOs, AI, machine learning, software defined, interoperability, do you think has the greatest potential? Who wants to start with the crystal ball question to conclude our webinar? Okay, Amir, thank you. Go ahead.
Yeah, what I see in the next 5 years, first of all, is the early phase. But what I see is network of networks. Network of networks is what 5G, 3GPP is following up. So right now we have release 16, 17, and probably soon release 18, which defines a satellite. We hope that the chip manufacturers for cellular, because the production rate is much higher than satellite chip manufacturers, are going to add our waveforms to the chip. So what I see is a network of network is a universal platform, which is mostly software defined, which is mostly virtualized, like a data processing is virtualized, orchestration is virtualized at the least of achievement on that. And all the decision making, like resource management is going to be based on machine learning and AI, like mobility prediction, weather prediction, all these things can be based on AI and machine learning. But the most significant advantage, which I really want to see, at least it happens in the next 5 years, is that the satellite network finally is going to be part of a whole network. It means the network of networks, and one module of that is going to be satellite. So satellite is not going to be something extra or something unfamiliar with the terrestrial network, and we have to patch it to the terrestrial network.
Thank you. Nimrod, I saw you nodding. Do you agree? Is that the most significant development?
I totally agree. I think the SATCOM, I think maturity is the word, and it will be more and more combined. I agree totally with Amir. Another point, I think that maybe it's not exactly my field, but I think security issues is going to be highlighted more and more, especially also because of the geopolitical situation. We see the war in Ukraine and so on. So I think there will be some emphasis on this one as well.
Thank you, Nimrod. Jack or Albert, what does your crystal ball say? Let's limit it to 5 years. Jack?
I think Leo definitely, and how to integrate that into the existing ecosystem. That's the challenge, and I think Leo, with its lower latency, will actually overtake. I think Amir's already said it. Overtake the terrestrial capabilities. So if it's easy to install and easy to operate, and the price point's correct, which it is already, never mind about 5 years, I think that's the way it's unstoppable. Geo will still have a place in the market, and like all natural markets, the pricing will be having to be adjusted to take that fact into account. So I'm hoping and praying that the satellite operators are listening to this and will make their adjustments accordingly. We've seen some movement, but nowhere near enough. I mean, by a factor of 100. I mean, that's how bad it is, or at least a factor of 50, you know, in terms of price per megahertz per month, what I call the golden number. That number needs to be significantly reduced if it's going to compete. At the moment, it's way, way off that, but there's legacy networks out there. So time will see. 5 years is a good time.
Well, Jack, I can guarantee you there are geo operators participating in this webinar. I cannot guarantee that they will listen and take your advice, but what we can hope. Albert, you had the final word before I sum up the webinar. So,
thank you. From our perspective in Orange Business is to become a service integrator and to move from an infrastructure operator, I would say, to a service integrator where obviously we will, the trend is there, reduce the part, the capex, the part of our infrastructure that is not required anymore, and to be to have the agility to integrate different access solution to provide agnostic access. That's the way we are. I mean, this is already initiated, but we still have a lot of infrastructure in place, and this is impacting our cost base, obviously.
very clear and very logical. Thank you. So panelists and audience, this actually does bring us to the conclusion of the webinar. And as I mentioned, the questions that we did not get to, we hope to post written responses in the next day or so, and you can see that at gvf.org as well. You will be able to see a recording of this as well as previous webinars at gvf.org. The next webinar is going to be on the topic of industrial IoT, the Internet of Things, the new satellite dynamic. It will be on June 29, the final Thursday of June, and at the same time, which is 3 p.m. in the UK, 10 a.m. in the US East Coast time. But it will be held under GSOA with the combination of GVF and GSOA occurring on June 1st. You'll be able to register for the webinar as well as all the other initiatives that GVF currently has, like our training program. It will continue going forward, and you'll be able to see this webinar on the YouTube channel, as well as at GSOA's website, which is gsoasatellite.com. And with this webinar, not only does it conclude the GVF webinar series prior to the combination with GSOA, it also marks my final contribution as I'm leaving GVF as announced back in February. So I want to thank the panelists, the audience, and really the entire industry for what has been for me a wonderful 4+ years, and wish everyone the best. And thanks again to our panelists and very much to the audience. Thank you.